All right, let's talk about some inscribed angles. So these are different from our central angles. Remember, our central angles went from the side of the circle to the center, and that's why they were called central angles. You see this angle inside the circle, it goes from the outside all the way to the outside, so it's A to B is a chord, and it connects with another chord, B to C, to create this angle right here, ABC. So B, this angle right here, this is our inscribed angle. So the definition: an angle with its vertex, well, on the circle with two sides that are, what did I say, A, B, and BC, where they are our chords. And this is our angle right here, inscribed angle. And this is its vertex. That's the angle it's talking about. An intercepted, I should change these colors, arc is the arc that lies between the endpoints of an inscribed angle. So here's the endpoints of that angle, and here's the part of the circle or the arc that is intercepted between those two endpoints. So what do we know? The degree of the inscribed angle is equal to half the measure of its intercepted arc. So remember when we had our central angles, they were the exact same. This angle would be the same as the arc. This time, the smaller one, the inside one, is half the outside one, or the outside one is 2 times the smaller one. So our measure of ABC, of angle ABC, would be 1/2 the measure of that arc A to C. So let's look and see what that means in our examples. Let's change my color. One moment, please. All right, we got this inscribed angle right here. That is not the color I chose. And we want to find what it is. This is asking for the measure of W, X, Y, so it wants to know the angle degrees of that X right there. 62 is our arc, so 62 divided by 2 is going to give me 31. 31 degrees is this angle right here. All right, let's look at this other example. We know this arc is 53 and this one is 65, so I need to do some math to find what this one is. 360 minus 65, 360 because that's the total of our circle, and that equals 242. So JML is 242. What's our question asking for? Measure of JKL, so we want this angle. Again, we're going to take that big arc measure, divide it by 2, and that gives me 121. So that K is 121 degrees. Next example. Here, we've got a triangle inside of our circle. And we've got this diameter, because it goes through the center, creating this triangle. So if you can't tell, whenever you create a triangle like this using the diameter, my green line, then this angle outside not outside, but not touching the diameter, is always going to be 90 degrees. We are creating with our diameter a right triangle. And why is that? Because the diameter splits the circle in half. The half of a circle is 180. So really what our angle, our big angle we're looking at is 180. So when we divide that by 2, that's 90. All right, we got some crisscrossies going on here. Let's look at what we want to find. We want to know what RST is, so this angle right here. And then we also want to know what RUT is. RUT is this angle right here. So let's look at them completely separate. Let's look at RST. So this RT is our angle. So we need to find the degrees there. Again, a little bit of math. 360 minus 75 minus 139 minus 64. And that gives me 82. So remember to find RST. We're going to say 82 divided by 2, and that is 41 degrees. All right, let's look at this other one, RUT. Oh, look, it's the same intercepted arc. So, same arc, same thing, same thing. So whenever I have some crisscrossy things like this, and we're asked for the angles, they're going to be the exact same. All right, down here uses our X. So this angle is half of this, so I need to take, the easiest way is taking 158 divided by 2, and that gives me 79. So D, this has to equal 79. So 8x minus 9 equals 79. Solve for x, x equals 11. All right, if the measure of STU, so this one right here, is 5x minus 16, and our arc is 12x minus 15, we want to find the measure of ST. So first we need to find x. We know again that this is half of this, or this is 2 times this. I'm going to use my second version of what I said to find this. I know that 2 times my inscribed angle equals my arc. So when I distribute, combine like terms, solve for x, x equals 9. In order to find STU, that's this one, I'm going to plug in that x that I found, and it gives me STU, which is 29 degrees.